welcome to finding volume with shells. So the general idea here is instead of using flat discs or washers, we are going to think of our solid as kind of a cylindrical onion. So an onion, of course, has multiple layers, kind of one inside the next and inside the next. So an onion is essentially built in layers. And so we are of sort of spherical shells. And so instead of spherical shells, we will use cylindrical shells. So the cylindrical shells are essentially the very outside layer of a cylinder, just looking at the sockets. So we essentially have a kind of like a paper towel roll, right? So it's kind of like looking at layers of paper towel rolls. So paper towel rolls have a very, very thin width, right? A paper towel roll has a width of just say delta X or dx. So the width is just delta X or dx, depending on how we want to view it. Then we also will have a radius and a height. So the volume of our paper towel roll, so the volume of a shell or the volume of a paper towel roll is just the circumference, so 2 pi r times the height times that little width, or times dx. Right? So as a general rule, when we go to use shells, shells work opposite of discs and washers. So if we rotate about the y-axis, then we are looking at some sort of shape. I'm just drawing a right triangle and rotating about the y-axis in such a way that we will have a hole. right? The shells that we are using will have a circle sort of as its base. And then a height. Which is the height of that part of the triangle. The width here is our dx. The radius here is our distance from out from the axis. So our width again is dx. Our radius is the horizontal distance out from the axis. In this case, we are multiplying, going around the y-axis. So we would just have, in this case, x minus 0. But it's whatever your axis is at. Our height is the height of our shell, right? So it's essentially the top of the triangle to the bottom of the triangle, right? So our height is basically just the distance from the top of the triangle to the bottom, wherever it is on the triangle that we are. Our formula for volume when we rotate about the y-axis, we do the definite integral from a to b in x. So wherever our first and last x values are. Then we have 2 pi times the radius in terms of x times the height in terms of x times dx. Similarly, if we rotate about the x-axis, then our shells are horizontal paper towel rolls. So we get our horizontal paper towel roll shells. Our shells will have width dy. So I'm just drawing a shell here. So our shells will have width dy, little thickness as in dy. The radius will be vertical distance from the axis. Our radius should be a function of y here. And then our height will be the horizontal distance. So essentially the horizontal total distance of the shell. Again, our height has to be a function of y since we're working with dy. And our volume is again a definite integral. This time we're going to be working with y values. So a definite integral from a to b of 2 pi times r of y, there's our circumference of a circle, times the height times h of y times dy. So sort of looking at these from the side, these look a little more complicated because we have these two separate formulas. We're not just working with radius now, but in the long run, these often can actually be easier to work with. It just depends on the function. So in the next video, we will go ahead and look at an example where we're doing shells in X, so rotation about the Y axis. And then we will switch into an example in Y.